Hi, everybody. Welcome to another Haas Talks Foss. I'm here with Karthik from LinkedIn. Karthik has presented at several Percona Live conferences about LinkedIn's scalability challenges, some of the things that they've done with MySQL, some of the cool things that they've learned and shared with us over the years. Hi, Karthik. How you doing?
Hey, hi Matt. I'm doing good.
Good,
Uh,
good. I'm great. And so you gave a couple talks at Percona Live, and I know that you've been at LinkedIn for quite some time now. Maybe just give us a little background on yourself.
yeah, sure. So I'll just talk about my whole career, how I turned to be a DBA, and then how I turned to be a database reliability engineer. I'll just cover my journey of how I aspired to become a database engineer. So way back in 2008, when I was out of the college, I joined Yahoo. So I joined as a service engineer, where I was. I mean, now the service engineers are called SREs. So at the time they were called as service engineers. I was responsible for handling the Yahoo's data pipelines. So I've been working there for like close to 1.5 year, and then all of a sudden, like we had hit a database issue. So while troubleshooting that issue, I developed more interest towards the databases, and I moved a database team. It was like I was just starting. It was kind of easy to move the teams. So I started when my skill was around 5.0 version. The first thing that I have done when I started was like I upgraded to 5.1. That was my
And that
first.
was a big jump from 5.0 to 5.1. That was a pretty significant, difference.
Yeah. So I still remember that it's just because of the partitioning feature in MySQL, we wanted to go with that upgrade, and I had to convince all my managers that we need to have this feature. So that's why we were going for an upgrade. And it was a like at Yahoo, it was like a massive scale. We had to upgrade like several. I mean, it's tens of databases, not hundreds of databases, but tens of databases. And later have worked for the Yahoo ad serving platform as a database administrator for close to 3 years, and then later I thought that I wanted to get more hands-on with the databases with wide range of technologies. Like we were using only the traditional MySQL, and but so I wanted to explore more. So I joined Python. It's a consulting company. So where I got chance to work on a wide range of it. Like I just worked on MariaDB, I worked on Galera, I worked on a Percona server. So lot of things have worked, and then I moved to Percona. At Percona, it was like amazing. Even though I spent only 1 year, but it was amazing journey. So I had a chance to work with the great startups. So at that time, there were like a lot of startups where I was consulting. I was part of the remote DBA team, and I was consulting for them. There are like prominent startups all over the world, as well as in India as well. So it was a great journey, and I learned a lot. And at the same time, each client comes with a different set of problems. Like it's not unique all the time. Like it's you have to be like on your toes all the time, and the clients are demanding as well. They expect the top class things from Percona. So I had a very good time at Percona, and later I moved to a startup where I was like stayed there only for 6 months, and then I moved to LinkedIn. So I've been with LinkedIn for close to 5 years. So in these 5 years, like I transformed myself from DBA to the DBE, like database engineer, and more importantly, reliable. I took the reliability part more. So in these 5 years, like when I started, there were only like probably 100 to 200 databases at LinkedIn. But over these 5 years, like the number of databases grew like more than 2,000 databases. I think it's like more than uh, 2,700 by now. I don't know how
Wow.
many it is,
Wow.
but it's like because the number of microservices are increasing crazily, and each microservice demands a database, and the database team is like very small. We had only like 3 to 4 guys in US and only like 2 to 3 guys in Bangalore. So it was very challenging for us. So how we scaled was like we automated everything, like right from provisioning, or like if anyone wants to do a schema upgrade or anything. So we have automated everything. So it's like we built an internal cloud for the databases. Like probably I can compare with like what RDS provides for clients, or how what Azure SQL provides for its clients. We provided the same thing for our internal teams.
So you have your own kind of internal database as a service for
Yeah.
your development teams.
Yes, yeah. We
Okay.
developed it from scratch. So yeah, it was a very good journey. Like I still remember, like when we were manually creating the databases when I started at LinkedIn. Now it's like a single click, they get everything. They get a high availability. They get automated backups, and if they want any schema upgrades, they can just submit a request and it will be done. And like there are still improvements though, like if you want to recover one click restore is not yet done, but that is in progress. And we have a ETL pipeline to any other storage, and we have the change data capture. Like you want from MySQL, you want to take it to some other store, we developed a change data capture pipeline where it captures the changes and then puts wherever you want.
And so
Um,
what did you use? Did you use any sort of like of the, like, are you using virtualization? Are you using, whether it's Ansible or Chef or Puppet for orchestration? Are you using any of the, containers? I mean, like maybe just give us a glimpse into that system. What are some of the technologies that you're using?
Okay, so for the databases, like since the number of databases are so high, and we hosted them on a physical bare metal server. And how we did was like we don't use the containers or anything. We have a bare metal servers, and we provision the databases based on the capacity. Like some team requests for let's say 1K QPS, and we have a cost factor for each. I mean, like it's not charge factor. I forgot the name, but we have a like we estimate the capacity of each server, and like let's say that the server can take 10K QPS. So if some team requests for 1K, and sometimes they request for only 100 QPS. So we provision all of them on a single physical server, and for security reasons we maintain the isolation. We leverage the MySQL privileges to make sure that the one database does not talk to the other. And we have the query analyzer tool as well, which provides like what queries are run, and it also provides an estimate of how much CPU are they actually using. Like it's not based on exact the queries, but we take care of uh, how much CPU. Like sometimes even though the QPS is like 100, they take huge CPU. So what we do is like we move them to another cluster where the QPS capacity is less. And of course, the disk quota implementation is like quite simple. Like they requested for, let's say, like 1 terabyte, and we extrapolate to like next few years, like how much it will become, like 1.4 TB or 1.5 TB, and based on the disk we have, we just provision. It's like a straightforward thing. And on top of that, we provide like the best practice, whatever the best practices that they can do. We help
Okay.
them in achieving that.
Okay. And so for that environment, that's a pretty big environment. Some of your bigger systems, they're running V-test, correct? Because one of the talks that you gave was about scaling LinkedIn, and it was specifically on using V-test. So
Yeah.
tell us how V-test plugs into that.
Yeah, sure. So we have a, system called Informed, which gathers like almost all the events at LinkedIn, all the infrastructure events basically. So we have hundreds or thousands of servers all the time, and there will be a lot of deployments happening on all the systems across LinkedIn. And each deployment is taken as an event. not only deployment, sometimes we some teams use that for alerts as well. Like if any alert comes or if some activity might be done on a particular host and what activity is done. So we calculate all these things, like which is a huge set of data. So like obviously like a single server cannot scale. So when they were initially launched, we were having them on a single server, but all of a sudden, since everyone liked this service, they all the teams signed up for this, and in a short amount of time we had to like quickly scale through this. So then we thought of Vitas because of like many factors. The primary factor is like it doesn't require any code change from the development team, because like their queries will still work fine. And other thing is like they want the transactional as well as the like relational features, like they want to still join on few tables. So because of all these factors, we started exploring Vitas, and it was like a quite obvious choice for us to go with Vitas, and it worked out well. And at that time, replication was at the native stages, so we could not use it. So we implemented our own replication strategy. How do we go to that and then come back? Like if something fails, but luckily for us, we never had to fail back at all. Like it's been running.
Okay, and 2,700 databases is a very healthy environment. What are some of the challenges that you run into trying to manage and maintain that size of environment? Like, what are the common things that continually come up that you have to kind of do?
Yeah, so I'll tell you, like I'll go a little bit technical. See, for example, we co-host the databases, right? So the main challenge that we face is the abuse from the clients. Like sometimes they miss a where clause, so they it updates like 1 million records or 10 million records, and we have literally no control on what they do, and they just start the transaction and they don't end it. So it leads
Oh,
to a huge undo log space, and it affects the replication lag as well. And apart from that, it becomes a noisy neighbor for the other databases, and they start complaining, "Hey, our database is slow. Like, what happened?" Then we have to follow up with each and every team, like what has gone bad. It's like very tough for us. We have
so it's really chasing performance problems at that point. It's
mm,
oh, this is slow. The system is impacting other applications and trying to find the needle in the haystack.
yeah, yeah. I mean, chasing the teams is one of the last things that we wanted to do. And at certain times, like we can't kill the connections as well. Like even if you kill, what happens is like it rolls back the transaction, which is even worse than letting it go. So yeah, we are trying to use proxy SQL or some other technologies like that, where it has very rewrite capability, where if someone accidentally misses a where clause, so it will not let it go. Something like that we wanted to explore, but it's like in the like very far. I would say I can't associate a timeline with that. But this is the one of the big challenge that we have. And the other challenge that we face is the query plan changes sometimes. So because our data is huge, and again, like we don't have any control on the query plan. Sometimes if it changes, if you want to force a new query or like give an indexing, we need to like go to the application, change the query, deploy it on all the hosts. It takes at least like half an hour to 1 hour of time. So that also we are trying to solve, probably like using proxy SQL or something like that, where it can automatically detect, and then I mean it doesn't need to detect. At least it can rewrite the query for us. We will save a lot of time. And also we are exploring the other options as well, like doing a like we wanted to prevent this problem before it occurs. Like can we have we'll have some a test server where we fire all the queries and see the pattern changes if the query
Yeah.
is going away with the data. So that we have not even scratched the surface of that, but this is just an ideation phase itself. So since you're not,
Yeah, I mean, there's a lot there because I mean, one of the great things about enabling, your developers and users to create their own systems, to be able to add, systems on their own, automate most of that is, it takes away a lot of um, the routine work of setting things up or installing or configuring, but then then you've enabled a lot more development teams to work faster, and they throw those problems at you quicker. And so then you've got to try and solve those issues that pop up.
yeah,
Because you're enabling the developers, they're developing, and sometimes they don't always get the things right. So there does need to be that closed loop.
yeah.
Now you mentioned you kind of moved from a DBA to a DBRE or a DBE. Has your role really changed that much? What responsibilities, but when you look at those two roles, a
Yeah.
lot more companies are moving away from hiring quote unquote DBAs and more are looking at SREs or DBREs. What's the difference? I mean, you've lived in both worlds. What do you see as the difference between those two?
Yeah, I mean, from my side, like when if I talk about me, when I was at DBA, I was looking at only at one system. Like I was making sure that one system is up or like all the time, and then making sure that the performance is not impacted. But when I moved to DBE role, like instead of looking at the system at a single system, I was like managing hundreds or even thousands of servers and account for the high availability of the systems and even make sure that they are like reliable, not just a single system but the whole environment. That's the major difference. Like I no longer run any alter commands or anything. It's all automated. I don't no longer run a backup or anything. Like it's everything is automated at a system level. Even the point in time restore, everything is like we have like a lot of tools to automate that. So that's a major difference that I see.
So it's about managing masses, lots of systems, but it's also being a performance detective, if you will, right?
Yeah,
So trying to find the needle in the haystack and
yeah,
find that performance issue, right?
yeah,
See, props. You come onto my show and you get props. But no, I get that, and it is a move that people have continued to see because you mentioned with the microservices, with the individual applications all requiring their own databases. You're no longer having 10, 20 databases that you maintain. You have thousands, and
yeah,
that's just it changes your mindset on how you have to work because you have to automate, or you'll die of overwork if you don't automate.
yeah,
And so I get that. Now you did mention HA and high availability, but that also goes along hand in hand with scale. And I know one of the things that you've talked about is synchronous replication versus asynchronous replication. And
yeah,
so you can't really do synchronous at LinkedIn because of the performance, correct? And
yeah.
so you're still advocating async. Maybe tell us a little bit about that.
Yeah, sure. I can talk a lot about this.
Okay,
Because
well, great.
we face this day in and out, and we actually we have both models. Like we talk to the developers every day and explain about the problems of synchronous replication. Like sometimes they demand like we want synchronous for this application, but we explain the challenges. Like I mentioned in the talk, like we are limited by the speed of light here. Light travels at a constant speed, and you are on the one side of the globe, and on the other side of the globe, it takes roughly around like zero point 0.5 milliseconds, I guess. But we can't tolerate that kind of latency. So that's why we definitely need to have async replication. But again, like the biggest problem that comes into the mind is the conflict resolution. Like how do you resolve the conflicts when there are multiple writes at same process? So like last writer win is like a very commonly used strategy across other databases as well, like across all the other distributed systems. So but the problem is MySQL does not have the native capability to give the any sort of conflict resolution, or even like for example, if you take Galera cluster, like there is no option to disable the certification process. because the certification process itself takes a lot of time. It has to communicate with all the nodes and get a act from all the nodes so that the site is certified. But that takes a lot of time, and there is no option to disable that certification process. And even if my application says it's my botheration to deal about the conflicts, or it's my botheration that I will take care of my data, but the any synchronous replication or anything, they does not let you do it. Like they, I mean, because that is their product, and it has to be. They give more weightage to the consistency part. So there is no option to disable. So that's why we had to take away the native replication. We had to go with the Kafka route, and then have additional application nodes to detect the conflicts, and then that applications, the additional applications behave as a writers, and then insert into the database on the other side of the globe. So this is all like very high overhead for us to maintain these systems. And like probably like if MySQL has natively provided that conflict resolution mechanisms, that would have saved us a lot of hardware costs and the maintenance overheads as well. Or even like if a Galera cluster can give an option to disable the certification process, and it can also it also detects the conflicts at the primary key level and rolls back. Instead of doing that, it can behave in an intelligent way and say that okay, this transaction I can skip, this transaction I need to override. So that kind of features, if it were there, it would have made our lives simpler.
Yeah. And you gave a whole talk on this at Percona Live, where you talk about the implementation that you're currently using, and you talk a little bit about what you'd like to use, correct?
Yeah.
Okay.
Yeah.
Yeah, and that is available for everyone who's watching this now on YouTube or on Percona's website, so you can go to get it for free. Go watch that. You can also watch about scaling, at LinkedIn as a whole. So Karthik does do, 2 talks at Percona Live, one on, the co-location replication, and one on VTES and LinkedIn. But Karthik, let me give you the final word. And I always like to ask people, what are they seeing that is going to change maybe how they work in the next couple of years? Like what kind of new interesting technologies or things are you exploring? What sort of, things are you really interested in right now?
Mostly I think like flexibility across the databases is the next thing that probably I guess. Like for example, if you are using MySQL, suppose you don't like MySQL, you want to move to some other data system. Like it should be like very seamless to move to the other database. So
So
probably
like moving from MySQL to Postgres, or from Postgres to Mongo, or from Mongo to Cassandra.
yeah. Yeah,
Wow. Okay.
probably like because of the changing of licenses, we don't know like which license changes at what time and when do we want to move. We are not sure, right? So probably that is the thing that I am guessing. I might be wrong as well.
Well, it's interesting because data portability is a big deal, especially with companies looking to prevent, getting locked into a certain solution. But as we enable developers often don't care about the database technology itself.
Yeah,
They just care about, I want to put data into an API, and then whatever's the optimal solution, whatever, as long as I just do the same call, I don't want to think about it.
yeah,
So that abstraction layer, you could change the back end of the database system from engine A to engine B, and it would be perfectly fine from a development perspective, but it might save you a lot of costs, resources, hardware, because it might be stored more optimally in a different database engine than it is currently. So I could see the value in that. So you're going to develop it? Is that what you're doing? Is that what I hear? You're going to develop that technology to move things around seamlessly?
yeah. I wish to do that.
Well, Karthik, thank you for joining me today. I appreciate you sitting down. I appreciate you talking at Percona Live. It was great to have you there. Hopefully, you enjoyed the show this year. It was great. A lot of people, a lot of different sessions. So Thank you very much.
Yeah, thanks, Matt. It's very nice talking to you,
All
and I
right.
enjoyed this as well.
All right. Thank you. Wow, what a great episode that was. We really appreciate you coming and checking it out. We hope that you love open source as much as we do. If you like this video, go ahead and subscribe to us on the YouTube channel. Follow us on Facebook, Twitter, Instagram, and LinkedIn. And of course, tune in to next week's episode. We really appreciate you coming and talking open source with us.